Hey, good morning, everybody. This is Mr. Ainsworth here at Grand Oak High School in 2024. We're going to get into lesson 10 here on how to graph inequalities in standard form. And there's a lot of basic skills. And so yesterday, when I was in class with you guys, I went over the first two examples. I talked and reviewed about how to graph a line and get an equality here in slope intercept form. And we talked about the rate of change, the y-intercept. We graphed the function. And we found that when it comes to an equation, okay, because x plus y equals 4 is called an equation, the line represents all the infinite number of solutions on the equation or for the equation. Well, when it comes to inequalities, that changes everything. Okay, so if you solve or have to graph an inequality dealing with either less than or greater than or less than or equal to or greater than or equal to, things change and the solutions are not on the line. They're below or above the line, as we found out yesterday. And then we also kicked in a little bit of Desmos here too. We typed in the equation, okay, x plus y is less than 4, and we found out what it looks like, and we confirmed it with Desmos, which is your best friend, okay? So you can check all your work in Desmos. And we talked about that. So if the solutions are not on the line, but either below or above the line, one of the two, like how do you do this quickly and easily without a calculator, right? Like Desmos. Well, it actually is not that bad. So let's get right into it. I started number 3, but let me finish it with you virtually here. And I'll do a couple examples in this video, and then of course you got to try a few on your own. All right, but let me show you some basic skills, okay? The first basic skill is how to isolate y. Okay, and we actually did this together in class, but let me just refresh your memory here. And when it comes to isolating y and getting into something called slope-intercept form, which is y equals m times x plus b, you need to get good at it. So I'm going to take this equation here. I'm just going to bring it down. So we have x minus y is equal to 2. We call that the boundary line. Boundary line. Okay, BL for short in our notes. All right, and what we want to do is solve for y and then graph the boundary line and test to see if solutions are either on it or off it and where they are. That's what we want to do. All right, so the first step is we're going to add the opposite of x here. And the opposite of x is negative x, so I'm going to add that to both sides. Again, we just covered this yesterday. And I get negative y is equal to negative x plus 2. Now I need to solve for y, so I'm going to do second step is I'm going to divide everything by negative 1, which will change the signs. Okay, and so what do we get? We get y equals positive x now, a minus 2, because 2 divided by negative 1 is negative 2. Okay, and you can see that the rate of change is 1. So I'm going to, which is your slope, by the way. So I'm going to write that down. The rate of change is 1. We can see that the y-intercept, which is where the function crosses the y-axis, is negative 2. We also reviewed that yesterday, too. So when you graph this line right here, let's start off at negative 2 here. All right, and the slope's 1, which is the same thing as 1 over 1. So we're going to go up 1, right 1. Okay, you can plot your points. So put your your pen on the negative 2 on the y-axis right there on your y-intercept, which is this point right here. It's called the y-intercept. And then go up 1 and right 1, and then go up 1 and then right 1, and plot a bunch of points right there. Okay? Okay. And then we got to figure out if the solutions are on the line or not. So before I draw the line here, okay, I want to check to see if the solution's on the line. And you can pick any point on the line. And if you pick the y-intercept, you're picking 0, comma, negative 2. So let's try that, 0, negative 2. And let's determine if the solutions are on the line. So it says pick some points and test them in the inequality to find the solution region. Well, that's what we do. We call them test points. So I'm going to test the y-intercept at 0, negative 2, and I'm going to substitute that in. So 0 in for x, and then negative 2 in for y. And so 0 minus a negative 2. Is that really less than 2? Question mark. Is that really less than 2? So let's think about it here. Okay, when you subtract the negative, you add the opposite. And there's a double negative there. So really here, we cancel both of these guys out. Okay, boom, boom. All right, and we get 2 is less than 2, which is clearly not true. Okay, 2 is not less than 2, so this is false. And when that happens, that tells you that whatever point you're using or that you're testing, again, we're testing here, is not a solution. So 0 comma negative 2 is not, okay, underline not, a solution to the inequality, which means that the points on the boundary line are not solutions. So what we need to do is we need to use the dotted line to represent that. So when you're drawing a line through these points right here on the boundary line, this is called the boundary line. Okay, we're going to make it dotted, okay, because dotted implies or means that the solutions are not on the line. Emphasize not, okay, on the boundary line. So then that begs the question, where are they then? If they're not on the boundary line, are they above it or below it? They got to be somewhere, right? Okay, and the previous example, we found the solutions below the line, but are they always below the line? Or are they sometimes above the line? I don't know. Let's find out. And believe it or not, there's no guessing. What you want to do is you want to pick a point and check. Okay, so we want to pick some points that whose difference here is less than 2. So this x minus y here is called a difference. We want to pick 2 points whose difference, okay, let's write this out in words, all right, is less than, come on, Ainsworth, so is less than 2. So can you guys think of 2 numbers whose difference is less than 2? And then what we can do is we can graph them and determine that. So one way is to think about it. And after you think about it, you can plot them. Okay, we want to find 2 numbers whose difference is less than 2. So how about, let's pick a point here. Let's pick a point above the line. So how about 1 comma 1 here? So 1 comma 1. And let's test it. So if 1 comma 1 is a solution, then we're going to shade above. If it's not, the solutions are below. So is 1 comma 1 a solution? Well, let's check it. So is 1 minus 1, is that less than 2? So let's work out the mathematics here. So 1 minus 1 is 0, and you have to ask yourself, is 0 less than 2? And it certainly is, okay? So that's a true statement, and that tells you that 1 comma 1 is a solution. So you got to ask yourself, where is 1 comma 1 located? And it's above the boundary line. And so if that's a solution, that kind of implies where the other solutions are. So the question is, though, are all the points above the line solutions? So let's pick another one just for funsies here. Let's pick, I'm going to pick the easiest point in the plane, which I suggest everybody tests, and that's called the origin. Okay, so 0, 0. So is 0, 0 a solution? Well, let's plug it in and let's check it out. So 0 comma 0. Okay, so you have to ask yourself, is 0 minus 0 is less than 2? Well, 0 is less than 2, and that's true. Okay, and because that's true, that tells you that 0 comma 0 is a solution as well. Okay, so let me see. The first point we picked, 1 comma 1, is a solution. So, and then, so I'm going to give it I'm going to just write down solution here. This one's a solution as well. How about the points below the boundary line? Like this point right here, which is at 3 comma 0, is that point a solution? So let's dive a little bit deeper. Let's try that point, and let's see if 3 comma 0 is a solution. So 3 comma 0, let's substitute that in, and let's check. So is 0, excuse me, starting with 3 here. So is 3 minus 0, is that less than 2? Well, let me see. 3 minus 0 is 3. And so is 3 less than 2? I don't know. I don't know about you guys, but I don't know. 3 doesn't look like it's less than 2. This is false. Okay, and what that means is that 3 comma 0 is not a solution. Not a solution. And so what you want to do is pick a point on either side of the line, and you want to test it in the inequality to see if you have a solution or not. And so I'm going to cross this one out. I'm going to write down not a solution here on the graph. And if one point that you pick is not a solution below the graph, that it kind of implies that the solutions are above the boundary line instead of below the boundary line. So grab a highlighter here. All right, and shade in the region above the boundary line. We call this the solution region. So a solution region contains an infinite number of points, and you can't plot them all, okay? So what we do in mathematics is that we just shade in the region that represents all the solutions, which happens to be above the boundary line. Okay, and then of course, what do we do? How do we check? How do we check? How do we check? What do we do? Well, we graph it. Okay, so put Desmos off to the side, bring it back in, and we only want to take a look at one equation at a time, so let's type in the new one here, and we get x minus y is going to be less than 2. All right, you type that in and then compare. And then click on your x and y intercepts, like these two right here. Click on them with your finger or your Apple Pen, and you can see that we have the same y-intercepts here. On the x-intercept at 2, on the y-intercept at -2. Those are called x and y-intercepts. So click on those points, and then you can compare your graph to the graph they have in Desmos, and you'll see that they're identical. And so you have a way to check at home. I'm going to screenshot this and bring it into my lesson so you guys can just see this right here. So there's a way to check it. I'm just copying it, and now I click on text box, paste it in, and then there you go. You can check your work as you go. Look at that. That's beautiful right there. Okay, and so check with Desmos here. Check your work as you go, and if you make mistakes, fix them, learn from them, and then you can get better and better and better. And then there are ways to do this even quicker without testing, but I'm not going to tell you until you figure things out, okay? Because there's ways to do this without testing all these points. And after a while, you'll start to get the hang of when are the solutions above, when are the solutions below, and so on. Okay. All right. I'm going to do one more example here, and then you can do numbers 5 and 6 on your own. Okay, let's go to example 4. And again, this is a video, right, guys? So as I say in all my videos and lessons here, if I'm going too fast, rewind it. Pause, play, rewind. Go at your own speed. And then when I come back, ask questions. All right? And then, of course, use Desmos and check your work. Okay. So here we go again. We got x minus y is greater than 3. Okay, so this symbol right here is called greater than. So in red, write down greater than. Bigger than, greater than. So we want to find the difference of two numbers that's greater than 3. Okie dokie. Okay, so now we're going to take this down here. We're going to write the boundary line. So BL for boundary line. So x minus y is equal to 3. Okay, you switch to an equal sign when you work with the boundary line. And then of course we'll graph it here. Okay. Let's get started. Okay, so add the opposite of x here first. So you bring down the minus y is equal to negative x plus 3. Divide through by a -1 on all three terms. And you get y is equal to x minus 3. Okay, so right away we see that the rate of change is 1. We see that the y-intercept is equal to -3, and that's where we graph on the y-axis. Okay, so we start at -3 down here on the y-axis. That's called the y-intercept. Okay, look right there. The rate of change is 1, which means we go up 1, right 1 from that point. So go up 1, right 1, plot a point. Up 1, right 1, plot a point. Up 1, right 1, plot a point. And you just keep on repeating yourself, okay? And you step it out. It kind of looks like a step, by the way. You step it out. All right? Tell the person next to you, step it out. Okay. All right, and then you got to decide our solutions on this boundary line. Okay, so you pick a point on the line, like the y-intercept. And you'll see me test this point every single time. So we always test the y-intercept because it is the easiest point to pick. Okay, it's called the y-intercept. All right, so what we do is we substitute it in our equation. So is 0 minus the y-coordinate, which is -3, is that greater than 3? Question mark. Okay, and you have to answer that question. So tell the person next to you, is 0 minus a -3 greater than 3? And if you said no, you're correct because you have to add the opposite here. 3 is not greater than 3. So that's false, okay? 3 is equal to 3, not greater than 3. So that's false. And that tells you that your test point, these are called test points. If I say pick a point to test, they're called test points. All right, is not a solution. And the way you're going to interpret that is that when a point that you pick on the boundary line is not a solution, you make it dotted, okay? Dotted boundary line. Every single time, okay? So make it dotted. This represents the solutions are not on the boundary line, BL's boundary line. Okay, so you only have two choices. Either they're above the boundary line or below the boundary line. So what I tell my students to do is always pick the origin because dealing with 0 is a piece of cake. All right, so the origin is 0, 0. So let's test it. Let's see if it's a solution. 0, 0. So you put zeros in. Is 0 minus 0, is that greater than 3? And just ask yourself, is that greater than 3? Well, 0 minus 0 is obviously 0, and 0 is not bigger than 3. This is false. Okay, what does that mean? It tells you that 0, 0 is not a solution. Okay, so I'm going to exit out. It's not a solution. This is going to make a note of it on the graph. Now, if you're wondering if we had to pick 0, 0, the answer is no. You can pick any point anywhere on the plane. But I always tell my students to pick 0, 0 because it's the easiest point on the plane to pick. If you wanted to pick 1, 0, you could. You can pick any point you want. So right now, if they're not above, they got to be below. So grab your highlighter and shade below. But just to prove my point here, we're just going to go one step a little bit further here. And we're going to pick a point below and prove that any point below is a solution. So if I was in class, I would ask you guys to pick. But I'm not there. So I'm just going to pick a point below, something really easy to deal with, like this point right here, which is 3, -1. And I'm going to test it. Okay, and the way we test it is by substituting it in the inequality. So here we go. So 3, whoops, getting a little crazy right there. 3, -1. Let's test it. And again, we test it in the inequality, which is right here. It's x minus y is greater than 3. So we have x right here, which is 3, minus the y value, which is -1. Is that bigger than 3? Question mark. I'm going to put a question mark there. Is that the case? We're testing that point right there. Okay, well, 3 minus the -1 is 4. Is 4 greater than 3? And the answer is yes, this is true. And what that tells you is that your test point, which is 3, -1, is a solution. Okay, it is a solution. So if you go back to the graph, I'm going to give it a happy face here. This is the solution region. Okay, and I say solution region because there's an infinite number of points below the line. And you can't plot them all, so what do? You shade it. And then you do what every good student does, and that means you check your work. So here we go. We're going to type the equation in. All right, x minus y is now greater than 3, and then check your answer. And I'm going to change the color. That's not the greatest. So let's go blue. There we go. Okay, and so you could verify everything you do in Desmos here. So I'm going to screenshot this and just bring this in. This is something that you can do. It's optional, but it's kind of cool because then your notes look really beautiful. All right, not that that matters, but uh, learn some iPad skills, guys, because what you learn in this class, you're going to take it to more advanced classes, as I keep telling you guys. This is just the tip of the iceberg when it comes to math. But as I always tell you guys in class, this is the most important class because if you're really good at Algebra 1, you're going to be successful in your other classes. If you barely make it out of here with a C minus or don't pass the class, then you should stop, retake the course until you get much better because everything depends on this course. Everything. Okay, I'm talking about all classes. I'm talking about math classes, of course. Well, I'm also talking about physics too, because if you don't know mathematics, you can't do physics, chemistry, and a lot of other things. So get really good. Okay, I'm going to pause here. This right here is homework. You got two additional examples here. You obviously want to do it together in class, so collaborate with the person next to you, get on task, work on examples 5 and 6, and then later on I'll post solutions in Canvas, okay? As with any video, they're available at home too, so if you need some more help, you've got it at home, all right? And this is Mr. Ainsworth. I gotta go, all right? I'll see you in class next time. See ya, bye-bye.